So alpha plus 2 beta cosine Ka. And you can see the periodic function starting to come into play because you have the cosine function coming in. So in real term, what does it mean? Let's take an example, right? For s orbital, if you look at s orbital and you try to calculate putting s orbital, let's say hydrogen atom, 1s orbital in here. 1s orbital is an exponential function, right? So you have 2 exponential function here and integrate together, and what do you get? You get a value, this beta value, which is here, when the quantum number are different. Beta value is negative, okay? So so it corresponds to a lowering of energy. So this is my S state, right? My original alpha is here. When you add this value, this magnitude of the value, beta is a negative value, so it actually lowers my function like this, okay? Now, if you're talking about P functions, right? A P function, this beta is actually positive, so it corresponds to raising my value. So this is my S orbital, this is my P orbital, and when you do it at the gap, it corresponds to raising and lowering of the gap in this case. Okay. So what when you do the MO calculation, what you see is alpha again plus a correction term, and depending on the sign of this correction term, you create a gap. So let me show you schematically what this looks like. Okay, so here we show in the bottom part first, right? So here we have S functions, right? So here I have S sigma, right? Meaning that my orbital, so this is my periodicity, right? This is my atom, atomic orbital, located at the period. If they are all the same sign, I get sigma orbitals, right? Like this. If they are alternating sign, I got sigma star orbital. So I get sigma S orbital or sigma star S orbital, like this. So if I have same sign, I correspond to this point. Okay, so I have alpha plus 2 beta. Beta is negative, so it's lower in energy. If I have sigma star orbital, it raised the energy. So you would have alpha minus 2 beta. Remember, beta is negative, so you have alpha minus minus is raised the top to become higher than alpha. So I correspond to this point. Okay. So basically, I have then this S state that I got like this as a function of different period. Now, if you look at the P orbital, right? So here I have my periodicity, right, like this. First of all, I have when the two sign, this positive negative term of my P orbital, when they combine like this way, I got P sigma orbital. If I combine in this way, I got nodal plane between atoms. It got P sigma star orbital. And so for this, it corresponds to this point, and for this one, it corresponds to this point. Okay, but the point is that if you do this, you find that at different K value, right, this K value here, you would get periodicity, and you get a gap between, because of the way they interact, right, the MO interact, you get a gap at different periodicity that you see, okay, which is exactly what you got in the case of graph function as well that we see earlier. Okay, so what we then say is that we call the graph function of 1D period is give you like this, and you can show that the periodicity is this U of X function as characterized by this. Okay. Okay. So today I'm gonna stop here. So I'll let you digest a little bit of this kind of math. Next day I won't do that much math, and I'll just describe to you the periodic functions, finish off the periodic function, and we'll move on to surface state. So you have an assignment due today.